Cloud Services Practice Manager and Principal Architect, which means, by and large, that what I do is talk to people who know very little about technology and help them try to understand really complex things. And then on the flip side, I get to talk to people who really understand technology and try to synthesize it into something that other people can understand. I was doing a talk not too long ago and was talking about how I've been in technology for almost 30 years. And then after the talk, I went back and realized it's more than 30 years now. So I've been around a while. I've seen a lot of different things. I've done everything from IT at the dev site support to running data centers, and I've been at Pinnacle for about 6 years now. And almost all of that time, I've had some focus on cloud. I realized early on that there was going to be some big changes coming in technology, particularly around the area of cloud, and I got really interested in it. And that's pretty much what I work in and around all the time. This is an example of a project that we're getting ready to start. We've got 2 separate cloud environments and 2 on-premise environments talking to each other, or at least that's the plan. I thought it was a little bit interesting way to get started. So, as I said, we'll see. My job is to make complex things simple in many cases, so I apologize if this is too simple. I gave this is a version of a talk that I give mostly to CEOs and CFOs to talk about what's happening in cloud. I'm really interested to get your feedback today. Clapping and boos and laughter are all welcome. The more I get feedback from you, the better I'll do elsewhere. And I really am interested in getting the feedback on getting your reaction and later on in seriousness, some conversation around some of the things that are coming. So we'll start. So once upon a time, there was one computer. It was a mainframe computer. We use mainframe for everything. Now, I say we, the mainframe actually precedes me just a little bit. Developers use COBOL and Fortran. Anybody here? No? See? Oh, there's one. There you go. Users sat at terminals and could accomplish amazing things. The developer's life was good. Then somebody invented the PC. And soon, we use PC for everything. That came along about here. Developers learned BASIC. Woo. IT ran from PC to PC. And technology life was hard. Then somebody said, PC needs a server. Developers learned DBase and C. IT connected PCs to servers. Users shared files and printers, and IT stopped running. While users played solitaire. Then someone said, the place for data is on the server. Developers learned Visual Basic and C++. The DBA was born. IT managed 2 tiers of systems. And someone said, we should centralize the servers and data. Now, I lived all of this stuff. All of this stuff happened in my career. So IT centralized all the servers and data. And users said it's too slow. To which we asked for more power, Scotty. It wasn't possible because physics got in the way. So then web and application servers were developed, and browsers were invented. Developers learned HTML and CSS. The web administrator was born. Now IT managed 3 tiers of computers. White hats and black hats were born. Users got let's get a good laugh. Or played online poker. And soon everyone sat at PCs and could accomplish amazing things. While IT kept things working. Then someone invented the internet. And mobile phones. And more browsers. Developers learned object-oriented programming, C#, Ruby, MVC, MVVM, and how to be agile. Developers made lots of money somewhere, someplace. The developer life was good, right? Then somebody said, why not cloud? IT developers, web admins, DB admins, CEOs, CFOs all said, what now? And I'm here to say I got your back. Which really means that I'm going to talk about cloud, and in all seriousness, there was some method to the madness in that preamble there. I want to talk about what it means as we're moving towards cloud and what's happening, particularly from an architecture standpoint. When we went through that, we moved from the mainframe to 2-tier to 3-tier. That's been, up until recently, the primary motivation, and it was all about getting more power to the different systems, more control. As we start to look at this, we start to see when did things happen? And it gets interesting when you look at where the adopted, where on the time frame adoption took place. And what you find is that about halfway through one of the phases, you start to really get good at it. And that these phases are roughly 10 years, thereabouts. And if you look at where we are today, all the way to the right, we're now starting to talk about SaaS, IaaS, and PaaS, all these cloud things. And we've already been doing that for about 5 years, which means the tools are really starting to take effect. We're starting to get access to the tools. We're starting to really get to the part where we're good at it, or where we have the tools to be good at it. And why did it change? Well, the first thing that we learned to do during the early PC and web phase was to scale out, to add more hardware, right? More CPU, more RAM. Then we learned how to add more servers, right? So that's really where we've been for quite some time. If you want more power, you put more web servers in front of things. If you want more power in the middle, you get more application servers, DBs, you cluster them and get them faster, right? That's what we've been doing. Well, now we're starting to see a new trend. These are scalable physically, but not application layers. So this is where we've been. And we're really still thinking about them as monolithic things. We talk about the customer app, the web app, the thing as a whole, even when there are multiple tiers. But now what's starting to happen is we're starting to get functional decomposition, which means that we're taking the applications and dividing them into pieces. And the reason for that is so that the application itself can be scalable where it needs to be. And the primary driver behind that is because in the cloud world, what do? You pay for what you use. And it's just like the light switch on the wall. And surely people remember mom saying, turn the light off, right? Because we have to pay for the electricity, or dad or somebody. Well, that's the same thing that's happening in the cloud world, is the finer your control over the resources that you use, the less you have to pay, the less expensive it gets. And so we're starting to see the application model change in some really big ways in order to take advantage of both the scalability and the cost factors involved in the cloud. Well, here's another way to look at that. We've been dividing horizontally for some time, divided the pieces apart. But now we're starting to divide the applications into pieces, and still across 3 tiers. This allows even more workload flexibility and scalability, allows you to take advantage of a lot of the pieces in the cloud. So, again, we talk about this idea of monolithic application. What do we mean? Well, this is your typical MVC, MVVM type application where you've got all the pieces together, you've got a single database, you've got APIs that surround it, and you're talking to different pieces, but it's still one thing. When you start to functionally decompose, start to talk about microservices, that means that each of these pieces talks to each other, and they're individual pieces. That looks really complicated, but this is what we're talking about, and this is the big change. When you see the SaaS applications that are running, folks that are doing a lot of AWS, I don't know if there's any exact time folks. I had a great conversation in January with them. They're all moving towards microservices as well. You have each of those tiers that I showed earlier. is its own complete piece, including the database. You're now starting each piece, each three-tier application or microservice, which can be scaled individually. Think about the concept that I give to CEOs and CFOs is that think about I created an authentication service, and I've got 100,000 people accessing the authentication service, but they're only authenticating and they're not actually hitting my main application because they've switched over somewhere else. I need to grow that authentication service as it needs to scale, but the rest of my application may not need to. And I want to do that individually. And that's where each of the, and the big change, the big thought change is separating the data. Because we've all gotten so used to not separating the data. It gets more complex as you start to talk across them, but that's really the big change. And this is not going to go away. Why microservices? Well, you know, it gets down to some core principles. Do one thing and do it well. Really focus on that one thing. It's isolated. If you can define the contracts between the different microservices, you can actually have multiple teams working on the different microservices at the same time. As long as you don't change the contracts, it doesn't matter. You can blast through a program, some functionality in a pretty big hurry. They can be created on demand. They can be updated independently. They can be scaled independently. You can leverage, and I was going to do some service fabric demonstrations at the end. I'm going to leave that to another time because it's a little more complicated. But you can scale, you can take advantage of the platform. Today, when we talk about disaster recovery, when I first started at Pinnacle, we did a disaster recovery project for a bank. And it was a 2-year project. And we had systems at both ends, and we were replicating all this stuff across. Now, today, if I want to do that project or something that's truly a cloud application or even just virtual machine, it's a checkbox. It's a checkbox. In our case, it would be an Azure or an AWS. You just say, yeah, I want that replicated somewhere else. So you can take advantage of some of these things, and we haven't even seen the beginning of it yet. And you can shut it down if you don't need it. Each microservice module can be scaled up or out independently across 3 tiers. So you still maintain that it's still quite common to see the 3 tiers, and they can be scaled for that microservice, but you now have the application divided across the boundaries. True cloud application. Use only the resources required, only when and as much as they're needed, while at the same time leveraging the always-on, always available features of cloud. That's cloud. What's happening is IT or the infrastructure pieces are becoming a utility that you pay for, that you get used to. Today we're seeing 15 or 20 years ago, 15 years ago, first thing I moved to the cloud was antivirus. I was managing it myself in the data center. It was just killing us. We were dying. And so we moved it up to what was then what would be considered a cloud, more or less. AT&T took care of it. It went away. We didn't have to deal with it anymore. Well, now we're starting to see email go that way, central file services, and the benefit to everybody in this room, more or less, is that we're starting to see the shift or the dominance of the developer. I really think that I often compare it to the baseball analogy, baseball fans, where are the pitchers dominant in this era or the batters dominant? Who's got the handle? Well, for a lot of time, how fast is the server, what kind of PC did you have, and determine what can be done. But now, all of that goes away. Today, anybody with a big enough credit card can get as much computing power as they want, just by turning it on. For the first time, it's really democratized the access to the technology. You have to learn new things, but you have access to it, and it's going to be the developers who understand how to use these technologies that are going to really be determining what directions we take. It's a new era. I think just like we don't talk about all of the phases in the that one tier side of the house. We just talk about it as mainframe computing. We don't talk about the phases anymore. All of this PC era, server area, 1 tier, 2 tier, 3 tier, another 10, 15, 20 years, we're not going to talk about it. We're going to talk about when people used to have stuff in their closet or in the data set, because that's not how it's done anymore. So what does it mean? The thing that I think is really important to understand is this is the biggest transition since the transition from mainframe to PC. That was an extremely disruptive change. You had IBM had people locked in. They didn't have any choice whatsoever. They're going to run a mainframe, run computers. You were going to use a mainframe, an IBM system, more or less. And then Bill Gates hoodwinked them and got the PC going, stole a little bit of code, depending on how you look at it, started up PC-DOS. But it was very, very disruptive. Things have changed completely from then. We're starting to enter that phase now in the cloud era. And what you're seeing with this is they're rapidly changing tools. Rob was talking to me this morning and said, I hate Azure. Now, I'm a huge, we're a Microsoft Gold shop.
Mad at it.
But his experience is common. I will tell you that you remember Bill, right? Rob and I were working on a project with Bill back at Pinnacle. He created a video for how to update the database for Azure SQL for a customer. And 6 months later, I went back to add some records, which should be easy. I watched the video, I went to the website, and there was no link. It was gone. The web interface had been deprecated, in this case removed, and replaced with SQL Server Management Studio, but only with CTP 6.2, which is a preview version. So I had to go get a preview version of the tool in order to access, and there's no notice, and I get 50 notices a day from things that are changing. So we're in that time of disruption where things are changing really, really fast, where ideas like microservices need to be grasped early, you need to get it and start working with it because it's rapidly moving. The thing that really woke me up was watching a presentation by one of the Microsoft project managers. He said he had an Agile team that had 2-week sprints. They were on sprint 69. They had missed one deliverable. That's because it fell on Thanksgiving Day. So they were pushing these every 2 weeks. They were either pushing changes to the cloud or they were preparing changes for the next push to the cloud. And that's my experience, is every 2 weeks, 4 weeks, part of Rob's frustration is that, well, they've got all this new stuff, but where's the documentation? It's moving really, really fast right now because we're in that period of disruption. But waiting for things to settle down is not the right idea either. So, what do you need to do? How many of you work in the cloud today? On something other than virtual machines? A couple, right? What I encourage you to do, I don't care whether it's AWS, whether you pick a Ruby platform, whether you pick Azure, it doesn't make any difference. Pick one, get used to it, but start working not in the VM phase. If you remember that time frame, what happens when we shift is we keep doing what we've always done. When the PC first came out, we wrote monolithic applications because that's how you wrote mainframe apps. And then somebody said, well, maybe it would be faster if the database was somewhere else, and so we started to shift. The same thing has been happening in the cloud era. It's super simple. I can actually copy the Hyper-V VM up to Azure and turn it on. It'll work. But I haven't changed anything. I haven't taken advantage of the technology and the tools. It's an easy way to migrate apps. It's an easy way to get them up into Azure. But it doesn't take advantage of the tool set. So as developers, your opportunity is you can get the cloud stuff. It's not horribly expensive. But don't work with what you know today. Start looking at the platform as a service tool. Start looking at how do I leverage the pieces that are there for developers to stitch together apps, and look at it in a new way. Don't write an MVC app. Go research microservices and understand how do you decompose, how do you talk to a customer to understand how to architect a piece of software that can be delivered as microservices, because that's a huge mind shift. start learning and experimenting. Everybody here, that's what we're here for, is to learn what's happening today. Get comfortable with Agile, DevOps. You're not going to be doing this cloud stuff if you can't deploy automatically, repeatedly, the things that you're doing. You won't be able to take advantage of it either. As I said earlier, microservices kind of simplifies the Agile development process, because if you've defined the microservices and you split it up amongst functional teams, actually one of the principles of microservices is to purposely assign microservices to different teams so they can't cheat. Right? The only way I can get my data to you is to send it to you, or that you can get it to me from my API. I can't access it through the database. But it complicates the way understanding how to build the software. One of the best folks, and I was trying to think of her name and I don't remember now, one of the spokespeople for Entity Framework. Julie Lerman. That's it, Julie Lerman. She's awesome. She's got stuff up on Pluralsight. She talks about how she struggled with domain-driven design, which is very much like microservice development, because you had to have separate databases, but that she's found it very, very beneficial. Understand the new architecture pattern, explain, explore different design methodologies that help, and then more often than not, and this is what Rob said he was struggling with today, you can't expect to drop into one of these new, particularly, Azure has been around for, I guess, technically 5 years. There's a lot of pieces. There are over 100 services that you can take advantage of. There are 20 or 30 patterns, architecture patterns, that have already been designed to take advantage of those tools. And you're not going to drop into them and start working on them easily. So start working with them and get used to it. And then get ready. Start thinking about, well, I know Rob's got schedules out to May now, which is great. But perhaps sometime this summer I want to come back and talk about Service Fabric, which is the tool set or the infrastructure that Microsoft deploys Azure on and Office 365 on. They've made it available to developers to use as their platform for deploying their services. You update the application, it's running across 3, 5, 10, 15 nodes. The infrastructure does the rolling upgrade for you, and if it fails, rolls it back. It's all automated. So get used to some of these new ideas. Any questions?
Hi, I'm working on a project by myself, and I easily see how I could transition into 3 separate microservices. But right now I'm using one database, and I'm using one project for the web and the API side. Mm-hmm. And I know I could easily split that into 2 databases or 3 databases: the authentication database, the front end web, and the web API database. But because I'm working on it by myself, it seemed like it would add a cost of it would slow things down a bit, in the sense that now I have these 3 different projects I need to deploy separately if I make changes across all 3. I see a lot of value in doing it in team environments, and other than just, taking the time to learn it for myself, do you see any value in me doing it on my own project that I'm the only one working on?
That's a really good question. And the best answer that I got was when I talked to the folks from ExactTime. They saw a huge dollar savings when they switched from infrastructure as a service as a platform to platform as a service, where they were writing in microservices because it's cheaper to use.
But he's on one server now, right?
Yeah,
so
I'm on one.
Could either have
right.
3 servers now, which would be more expensive, or...
So the answer is, or I guess my answer is, that the benefit is that it's a big mind shift. And so learning to do it will pay dividends in the long run.
Mm-hmm. I see value in that.
And that's where it is. It's taking the time now. So is it particularly valuable at this moment? Perhaps not. It sounds like it's an MVC app or something like that. That's pretty typical. Is it going to pay benefits for that program? Probably not. But just looking through, how do you determine where the boundaries are between the different pieces? And more importantly, how do you, when you really get into the architecture design, when you're splitting it up that way, you talk about not a login screen and the middleware and the back end being separate services. but my accounting section is a different service than my sales section, and they both have customers, but they're not in the same database, and a customer in accounting is not the same thing as a customer in sales. And understanding how to design and architect the solution so that works, and then resolve the differences as you move away from relational databases to, I don't really care what the database is, because the microservice is separate, and it doesn't make any sense. Those are big shifts.
So with that example you just gave, kind of keeping two different customers separate, then how do you kind of have them in sync? How do you keep them in sync?
That is the reason to do, that is the answer to his question.
Because
How do you do it?
Situation, something I'm doing, and I'm just kind of wondering.
There are, that's why to get started using the tools, because there are different architecture patterns to resolve some of the questions. Some of the answers aren't baked yet. So it's early enough that you're at, it's not too early, but you're at the time when you can start to learn as it develops rather than after the fact. I really expect we'll see more completely developed tools. Like, Rob, how long has NBC been out? I mean, real?
I'm trying to think here.
5 years?
NBC 3 was out when I joined Pinnacle in 2015. I think it just come out. I mean, the pattern's been around a lot longer, but ASP.NET
Sure.
NBC has not been around.
And that's what I mean. ASP.NET, where the tools, where it was baked into Visual Studio, it hasn't been out that way. And we're at the end then of the 3-tier traditional architecture, and we've been now in cloud for already 5 years. We should start to see the ready-baked tools, the things like Service Fabric that does a lot of the back-end stuff for you, starting to hit here in the next few years, and the time to get ready for that is now.
So you had mentioned that as long as none of the messages are going to change, most times you can seamlessly upgrade with no one noticing. However, if a team were to make a change, are there tools in place that you can exercise your end-to-end test, as it were?
That's where I was talking about the DevOps side. The folks, I mean, you're talking about continuous delivery. There are some, particularly SaaS-based solutions where the developer's first day on the job, they push active code to the cloud. And that's because they have built into their infrastructure automated QA, UAT testing that not only will test before it deploys, but then they're monitoring key KPIs so that if all of a sudden revenue, which is running at $100,000 an hour, drops to $10 an hour, well, the code that was just deployed, something wrong with it, and they'll roll it back automatically. So yes, there are, and it's another piece of that learning how to do, because that's not simple stuff either.
Another thing to keep in mind is that sometimes, like you say, what if there's breaking change in the API? Well, this team over here needs my new stuff. That team over there still needs the old stuff. There's nothing wrong with in your when you deploy your API, starting with /API/v1/v2, and you can deploy multiple versions of an API at the same time, and that a team can upgrade, that some other team can upgrade to the new API when they're ready to. Plenty of semi-public APIs out there do this kind of thing, where they work out another version of it, they deploy it under another route, and then make that available so that you can use the V2, but V3's got all these new features. Don't you want to switch over?
And occasionally you get breaking changes which are,
Sure.
you just have to do. Yes, it is an issue that has to be dealt with. More questions?
It's probably a dumb one then. So he mentioned that he has a single application, a single monolithic application. If he did want to switch to microservices, can he still do that on the one machine, or does he have to have multiple machines?
No, you can do it on, I mean, it can all run on the same machine. But the key to it is that when you're really doing microservices, and it's true, it's especially true in Azure, the platform as a service tools that are available on Azure are themselves microservices, so you won't actually deploy to a server. The concept of server disappears in a pure cloud environment. You deploy to a cloud service, you consume other microservices to build your microservice itself, And so you're not deploying to a server. It disappears because you don't care about that. Anything else?
A lot of these, a lot of these providers, the idea, and there are other advantages if you think about it. It used to be the sort of bridge to getting to microservices in the cloud was, well, we'll go out and we'll put a bunch of VMs in EC2 or DigitalOcean or whatever. And the problem with those is someone still has to manage those. Someone's got to do security updates and this and that, and that VMs take time to spin up, spin down. There's a lot more that goes into managing VMs. Whereas if you can, one of the big selling points that Agile put out there was you can literally just deploy your MVC app straight to the cloud. There's no, we'll take care of the rest, and that's the difference. And I'm not sure which one's which between infrastructure as a service and platform as a service. Infrastructure as a service being
all of the backend stuff is managed for you. You don't even know what it sits on or care.
Right.
Yeah, like the app I'm talking about, I have it on an Azure website, so I don't care about like what operating system it's running on. I don't update anything. It's awesome. I love it.
And that is a cloud service.
Mm-hmm.
It is a microservices, but you actually can log in to the server and you can get into the Nintendo if you have a, but to all intents and purposes, you don't know or care what it is. And if you want it to be bigger, depending on where you are in the stack, you click the box and it's bigger. It just happens. Sometimes it reboots and sometimes it doesn't. It's just bigger. And the application can automatically scale so that when you hit a certain CPU side utilization or a certain memory limit, it adds another one. And then and you can do some of this through the DevOps side where you're monitoring the cloud service itself. But you just tell it, okay, if you've been at 80% CPU utilization for 5 minutes, I want you to add more CPU power. And then if it tails off to 40% for 30 minutes, then I want you to drop down again. Or you can put it on the schedule, and we're talking about the login side. If you're not in a round-the-clock situation, then maybe you want, at 8 o'clock at night, you want to shut it all the way down so that almost nothing is running, but it's still up in case somebody's up at midnight. And that can all be automated. So then you're starting to focus on what does it cost me to run this? Because the Kool-Aid that all of the cloud people are selling is that it's cheaper to rent a car, to lease a car, than it is to buy one. And that's only true if you buy a new car every time a new model comes out. Then it's cheaper to lease. And that's what's happening with all the Office 365 and things, is that you're leasing software. You're leasing access to the computing resources. The benefit, and the amazing thing that's happened in the past year, is the rapidity of the adoption by the business community. There were barriers a year and a half ago that no longer exist. We're working with CFOs who 2 years ago said, you will get my ERP system in the cloud under my cold, dead fingers. And now they're saying, when can I move it? Because they're at the end of a life cycle, they've got to buy new hardware, you're looking at $100,000 in capital, and the IT resources to manage and patch and do all these other things, where I can offload it to somebody else and I don't have to worry about it anymore. Plus, the one that caught me by surprise was we got people moved to email in the cloud, and they're like, wow, this is awesome. My PC, my laptop, my phones, my tablet, they all work, I don't have to worry about it, but VPN sucks. How can I get my files to be just as available? And that's been the next wave from the business side, is how do I make my files available? And then once they've gotten used to this idea that I'm paying so much a month per user, then do I really have to buy new servers? Can't I just put them in the cloud? None of these are really taking advantages of what I'm talking about here. This is old style stuff, except, Microsoft builds Office 365 in the same way. The really cool apps, the things, the Unity, all of these things, if you're going to put them in the cloud, you're not going to want to, you're going to pay as little as you possibly can for the resources to run that application, and the way to do it is divided into small pieces. Okay? Thank you.